Hello everyone, this is Lalita Singh and you are going to study science with me in class 7. Today we are discussing first part of our chapter 4 that is called heat and temperature. In this chapter you will learn about what is heat, transformation of heat energy, temperature, thermometer and conversion of temperature scale. See over here, this boy has been running for a long period of time, that is why he felt hot. Okay, and he started to sweat. Do you know why he feel hot? Actually, the boy has been running. Running means he is doing some kind of work. For doing work, he need energy. What kind of energy has been used over here? It was muscular energy that has been used. And when the energy get used, it transform into other form. We know that energy cannot be created neither be destroyed, it only changes form. It means when the boy was running, he has used his muscular energy, and later on this energy has been converted into heat energy. In the same manner, when we touch the grinder after using it for grinding spices, the grinder become little bit hot. The reason is over here electrical energy has been used to grind the spices. Means electrical energy has been used to do some kind of work, and after doing work some amount of energy has been transformed into heat energy. If you are hammering a sheet of metal, it becomes flattened, but with being flattened it also become little bit hot, because over there we are using muscular energy, and this muscular energy after performing the work turn into heat energy. Understood? We use any kind of energy to do work, some part of it will always turn into heat energy. Understood? You may have noticed when we boil water or when we cook rice, okay, we cover the utensils, the lid is covered with the small plate, okay, and when the food is being boiled, what happen, the steam will come out from its mouth, and the steam will push the lid, and maybe the lid get fall down. This happen because over there heat energy is produced by burning the fuel, and this heat energy changes the water into water vapor, which pushes the lid out of the way. Okay, so whenever we do any kind of work, like rubbing hand, like running, like hitting or grinding, over there always a small amount of heat energy is produced. The heat always dissipate from its source into surrounding, making the surrounding hot. Understood? Like if you are working in a kitchen, you will not feel cold during winters, and it will become intolerable when there is summer. Why? Because over there heat energy is keeping the environment warm. Clear? Now, transformation of heat energy. Heat energy can be transformed or changed into other form. For example, in thermal power station, we use coal as a fuel to produce heat, and this heat energy is later on turned into electrical energy. Even in steam engine, heat energy is being transformed into mechanical energy so that the steam engine can move. In the same manner, there are certain other examples where we use different kind of energy to convert into heat energy. For example, this is electrical iron. To iron a cloth, we use electricity. Electrical energy is being converted into heat energy in this case. See, this is a geyser. Geyser also uses electrical energy to keep the water warm. So, it is also using electrical energy to convert into the heat energy, and this is room heater which is used to keep the room warm, and over here also electrical energy is used to transform it into heat energy. Even when you rub your palm together, mechanical energy, muscular energy is being used to convert it into heat energy. When we are rubbing palm together, muscular energy is used to convert it into heat energy. There are some places where formation of heat energy is intermediate. Means it is an intermediate condition where the heat energy is produced. Okay. means there is another kind of energy which changes into heat energy, and later on they change into the third kind of energy form. For example, in case of electrical bulb, we supply electricity to the bulb. Okay, means we are supplying electricity, electrical energy. Electrical energy will warm the filament, it heat the filament. Because of heat over there, the tungsten filament started to shine and produces light energy. It means heat energy is intermediate condition. Understood? In nuclear power station as well, the nuclear energy is transformed into heat energy first, and then later on this heat energy is being transformed into electrical energy. It means heat energy is intermediate condition here. Now, next topic is hot and cold. As we know, when a body possesses heat, it tends to become hot. Whenever a body has any object is having heat, it will become hot. On the other hand, if the body loses heat, then it will become cold. For example, during summer, when we sweat a lot, if there is a cold wind breeze, it will pass from your body, you feel suddenly cold. Why? Because the heat energy of our body has been used to evaporate the sweat. In this way, our body get cooled down. Clear? In our day-to-day life, we find object either hot or cold. For example, ice cream is cold, whereas a cup of tea is hot. Now, the question arises, how can we say that there is some certain substances which are hot and certain substances are cold? Actually, we compare them with our body temperature. When we are saying something is cold, it means it is colder than our body temperature. When we say something is hot, it means it is hotter than our body temperature. It means we are simply comparing the heat energy possessed by the object. Normally, we feel hotness or coldness of an object by touching them. But as we know that our senses are working over there, so our senses are not reliable, because if you have suddenly touched a very cold object like ice, and then you will touch a normal room temperature water, the water will become warm for you. Understand? And if you have touched a hot glass of water and then you will touch the normal room temperature water, it will become cold for you. So we cannot rely on the sense of touch to judge a thing that it is hot or not. It can be easily understood by activity number 1, which is to feel the hotness and coldness. Over here, this child is having 3 bowls of water. First one is carrying, A is carrying ice cold water. Okay, and B1 is carrying hot water, whereas the C is carrying lukewarm water. Now see what he is doing. He has taken these 3 bowls and named them accordingly and fill up them with water. And now he has placed his hand in A and B, means ice cold and hot water. Okay, now just think what you will feel when you are standing in his condition. The cold water will be kind of very cold, right? And this warm water, hot water will be felt like hot. Okay, but when you are placing your hand into C, okay, the hand which was in A, if you are going to place it in C, you will feel slightly warm. Okay, or if you are going to put your hand which was in warm water into C, you will feel slightly cold. Understood? So the left hand feel the water and the right hand is also feeling the same water, but the water temperature is felt by us in different condition. It means the hand which is in bowl A felt that sea water is kind of hot, right? But the hand in bowl B, when placed into the C bowl, what will happen? He will feel that water present in C is kind of cold. Understood? So we can say that we cannot rely on our sense of touch. Clear? So there is a need to measure the temperature. And to measure the temperature, there should be a reliable method so that we can judge the temperature. Understood? We often say that ice cubes are kept in freezer are very cold. The water that comes through the tap water in winter is also quite cold. The teacup is kind of very hot. Okay. The term cold and hot or warm or very hot are often used by us to describe the physical property of matter. These terms are relative. It means we are just comparing them with our body temperature. And again I am telling you that we are just comparing the temperature of object with our body temperature. Okay, so the temperature is the measure of hotness or coldness of a body. We measure them with the help of thermometer. The instrument that is used to measure the temperature is thermometer. What is temperature? Temperature is measure of degree of hotness or coldness. What is the condition of the object in sense of hotness or coldness? The temperature is measured by the use of thermometer. There are different kind of thermometer. You can see this is a kind of thermometer. See, this is a second kind of thermometer, and this is also a thermometer. We are having plenty kind of a thermometer which we are using in our day-to-day life. Clear? These all thermometer is used to measure the temperature of different material or object. The two common thermometer that we are going to study is clinical thermometer and laboratory thermometer. Okay, and the scales that are used to measure the temperature, the very common two scale which are used to measure the temperature are Celsius and Fahrenheit. Beside this, we also use Kelvin to measure temperature during some of the experiment. Clear? Now, what is Celsius and who gives the Celsius temperature? In 1742, a Swedish astronomer called Anders Celsius proposed a Celsius scale. Okay, this scale actually bear his name. The most commonly used scale is Celsius scale in our country. Okay, according to this scale, the 0 degree centigrade is the freezing point of water, whereas 100 degree centigrade is the boiling point of water. It is not a coincidence. It is not a coincidence because he has actually taken the freezing point of water as 0 degree centigrade and the boiling point of water as 100 degree centigrade. And the distance of temperature, okay, has been divided into equal units. How many units? 100 units. Okay, and then every unit is considered as 1. The temperature is increased by 1 whenever we pass the previous unit. Understood? The reading taken in degree Celsius is always written with degree C. Okay, degree C indicate the unit degree Celsius. Along with the numerical value, it is written degree C. Okay. For example, see, it is written 98.7 degrees C. It means degree Celsius. Understood? Now about Fahrenheit scale. The Fahrenheit scale was devised by a German physicist, Gabriel Fahrenheit, in 1714. Okay, it was discovered earlier than the degree Celsius. Okay, on this scale, water is boiled at 212 degree Fahrenheit and freeze at 32 degree Fahrenheit. You can see in this table it is given. Boiling point of water in Fahrenheit is 212, whereas in centigrade it is 100 and in Kelvin 373. Now what is Kelvin scale? The Kelvin scale was given by Kelvin. It is also a type of scale which is used to measure the temperature. According to the Kelvin scale, the freezing point of water is 273 Kelvin. And the boiling point of water, we just have to add 100 into 273 and we will get the boiling point of water, that is 373 Kelvin. Therefore, by adding 273 in any degree Celsius, we can convert the degree Celsius into Kelvin Celsius. So see over here, 100 plus 273 is equal to 373. Clear? Now, freezing point of water is 32 degree Fahrenheit. In degree Celsius it is 0 and in Kelvin it is 273, whereas normal room temperature is 72 degree Fahrenheit and in degree Celsius it is 23 degree Celsius and in Kelvin it is again 273 plus 23 is equal to 296. Now next is conversion of scale from one scale from other. See, this is the formula. Degree centigrade by 100 is equal to degree Fahrenheit minus 32 divided by 180 is equal to K minus 273 by 100. This is the relationship between these three kind of scale. By mathematical expression, by using mathematical expression, we can convert the one data into another unit. Understood? See over here. Here, to convert from degree Celsius to degree Fahrenheit, the simplified formula is given, that is C by 5 is equal to F minus 32 divided by 9. See how we are getting this formula. See over here, this is the main formula, right? Degree centigrade by 100 is equal to degree Fahrenheit minus 32 by 180 is equal to K minus 273 divided by 100. Now we are going to convert one scale from another. Okay, over here conversion between degree centigrade and degree Fahrenheit is given. So basically whenever we are converting, we will choose those section of this formula. For example, if we are talking about conversion between the degree centigrade and degree Fahrenheit, so we will write only this section. Okay, and if we are converting between the degree Fahrenheit and degree Kelvin, then we will choose this section. Or if we are converting between the degree Fahrenheit and between the degree Kelvin and degree Celsius, then we will choose this section. So depending upon what we are converting into which. Okay, so we are going to choose the formula. Right now we are going to convert degree centigrade and degree Fahrenheit into each other. Okay, so we will choose this section of the formula, and that is what I have written over here. See, degree centigrade divided by 100 is equal to degree Fahrenheit minus 32 by 180. Understood? So this is the formula which we have taken from the above three scales relationship. Okay, now what we will do, we will transfer this 100 from here to here. Understood? So it will become degree centigrade is equal to degree Fahrenheit minus 32 divided by 180 into 100. Now we will cancel out these two from each other. So 0 0 will get cancelled and 9 2s are 18, 5 2s are 10. It will get cancelled out as well. Okay, now next what is this? Next step is, it will be written in simplified form. Degree centigrade is equal to degree Fahrenheit minus 32 divided by 9 into 5. And then this 2 will be written together in the front portion. This is nothing changed if we are writing in multiply in the front side or back side. So I am going to write it on the front side so that it can look at least a little bit better. Understood? So it will become degree centigrade is equal to 5 by 9 into or bracket degree Fahrenheit minus 32. Clear? Now next, second part of conversion. See over here, when we are trying to derive degree Fahrenheit from the degree centigrade portion, what we are supposed to do. We are again going to write the same formula. Understand? We are writing the same formula from the 3 temperatures unit formula. Okay, relationship between the 3 which is given on the book. Okay, we are taking just same thing. Now what we are going to do, we will separate degree F from others. For that we need to transfer first 180 to this side, as over here it is in divided condition, here it will become in multiplied condition. Understood? Now 180 is transferred on degree centigrade sign and it will be written as a degree Fahrenheit minus 32 is equal to degree centigrade by 100 into 180. Understood? In the next point, what we are doing, we are cancelling 100 with 180. 180 into degree centigrade or degree centigrade into 180. Both are same thing. So I am writing this as this. Understood? So over here we are cancelling it out from one another and it will become like this. Hopefully there is no problem in simple mathematics. And then we will transfer this 32 from here to this side. As we know, it minus become plus when it transferred to the second side of is equal to, right? So when minus 32 is going to get transfer on the second side of is equal to, then it will become plus 32 and that is what written over here. Understood? See, degree Fahrenheit is equal to 9 by 5 degree centigrade plus 32. So this is your second equation, and these equation can use to change, see over here, degree Fahrenheit to degree centigrade and from degree centigrade to Fahrenheit. Okay, if we are having data of degree Fahrenheit and we have to change it into degree centigrade, then we will use this formula. Okay, we will use this formula if we are having data value of degree Fahrenheit. Okay, and if we are having data of degree centigrade, then we will use this formula if we want to convert the degree centigrade into degree Fahrenheit. Clear, everyone? Now, next, see over here, it is the relationship between degree centigrade and Kelvin. Okay, how we are going to transfer one from another? See over here, because of the formula, by the formula we can say that degree centigrade by 100 is equal to K minus 273 divided by 100. See, it is given over here, degree centigrade and Kelvin. We will take this formula and that is what written over here. Now after doing this, what we are going to do, see over here. Okay, degree centigrade, if we want to convert into Kelvin or we want to convert Kelvin into degree centigrade, so first we have to make it alone. If we want to find out how many Kelvin is going to become degree centigrade, so we will do this like this. Degree centigrade is equal to K minus 273 divided by 100 into 100. We will bring this 100 over here, and here it is in divide condition, over here it is in divide condition, so here it will become multiply. Okay, it will become multiplied in condition. Now, so it will be written like this, degree centigrade is equal to K minus 273 divided by 100 into 100. So 100 and 100 will get cancelled out with each other and the remaining will be like this, degree centigrade is equal to K minus 273. Or if we want to find out K, then we will transfer this minus 273 to this side and it will become K is equal to degree centigrade plus 273. Understood? Clear, everyone? Now this is the formula here which we have find out about conversion between Kelvin and degree centigrade. Now next is conversion between Kelvin and Fahrenheit, which is not mentioned in the book. So what you are going to do, just solve the mathematical expression between Fahrenheit and degree Kelvin. Okay, over here it is Fahrenheit and it is Kelvin. So we will take this portion of the formula and we will write it over here like this. Understood? And we will make alone the F degree Fahrenheit will have to be alone over here so that we can find out the value of it. So we will send 180 from divide position to multiply position and it will become like this. Understood? Now next is what? We will cancel these two with one each other. These and this is going to get cancelled. 180 divided by 100, and after cancelling it will become 9 and this will become 9 and this will become 5. Okay, so after that the formula will become like this. Degree Fahrenheit minus 32 is equal to K minus 273 into 9 by 5. Now this can be written in the front as well, so we are going to just write it like this. Clear? After that this minus 32 will be transferred from here to here and it will become plus 32, and this is the formula that you will use if you are having the value of K and you want to find the value of degree Fahrenheit. If you are having value of Kelvin, then you have, and if you want to find out the value of degree Fahrenheit, then you will use this formula. Clear, class? Now next, now the question arises, what you will do if in question you are having the temperature reading in degree Fahrenheit and you are asked to change it into Kelvin. Then we will apply this method. This is the same formula that we have taken from the relationship of 3 temperature scale. Okay, now what we need to do, we need to find out it in Kelvin. So we will make the Kelvin alone. For that we will transfer 100 from here to here, and because of it the divide 100 will get over here as in the form of multiply. Understood? Then see what will be remaining over here in this side. K minus 273 is equal to, it will become degree Fahrenheit minus 32 divided by 180 into 100, right? Like this, into 100. Now next is, after doing this we will cancel out 100 with 180, and after cancelling out it will become 5 and 9. Over here 9 and over here 5. Now after that we will write it as 5 by 9 in the next line. Okay, so it will become K minus 273 is equal to degree Fahrenheit minus 32 into 5 by 9. Understood? Now next is, after that we need to separate this minus 273 as well from the Kelvin, and for that reason we will transfer this minus 273 to this side. Okay, and it will now become like this. Understood? It will become like this. K is equal to 5 by 9 into F minus 32 plus 273. We have done nothing special, just change the location of this one from here to here, from back to the front, and then we will write down this 273 from here to here. This is how the conversion of one scale take place into another scale. Hopefully you understood it clearly. Okay class, that's all for today class. In next day we will start from the next point, that is structure of clinical thermometer. Okay class, then have a nice day.